this. You're going to be using z-test, guys, if and only if the population standard deviation is given. Okay? You're going to be using t-test if the population standard deviation is not given, meaning it's not known. It is not mentioned in the problem at all. Instead, what is given is the sample standard deviation. So when the sample standard deviation is given, that's when you use t-test. Okay? So I hope it's clear. So if you notice this symbol here, guys, kaning red na murag circle na naiikog sa babaw, that's a symbol for population standard deviation. Okay? And with that being said, if it's not given or unknown, then you have to use t-test for a mean. The formula is still the same, or not technically the same, but similar to z-test. However, for t-test, guys, there is an additional step that you need to consider, which is the degrees of freedom. And for us to be able to understand better as to what's or how to use t-test, let's proceed to the example. So here, I have discussed this last time, but I'm not sure. I'm gonna try to rediscuss this. A medical investigation claims that the average number of infections per week at a hospital in a particular area is 16.3 Dow. And then, a random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. The question is there enough evidence to reject the investigator claims at alpha 0.05? Assume the variable is normally distributed. So first, after you read the problem, after you understand the problem, guys, you then pre-qualify it. Kung sa man, sir, do I have to use t-test or do I have to use z-test? That's the very first question that you're going to think about. Now, sir, the qualification for you to be able to use a z-test, dapat daw, the population standard deviation is given. That's z-test. And if the population standard deviation is not given, meaning to say it's not unknown, you should be using t-test. So based on the situation in the problem, the given is sample standard deviation. This means to say that we are going to use t-test instead of z-test because the population standard deviation is not given in this case here. Instead, the given is the sample standard deviation, okay? So we are going to be using t-test for this problem here. Let me take a screenshot of this and paste this to our whiteboard. There. I hope you can see this. All right. So the steps are still similar, guys. It doesn't actually change at all. It's just that the values, the critical values, and the value of the test statistic is different compared to the z-score. So let's start with the first step, which is the null hypothesis and the alternative hypothesis. So the null hypothesis that we have for this problem, guys, is mean equals 16.3, right? And the alternative hypothesis is going to be alpha mean not equal to 16.3 because it didn't actually tell here if it's less than or greater than. So if it's not telling us specifically, so we're going to be using the not equal to. And then the claim here is the null hypothesis. There. Next, step 2. So this is where the difference of process will kick in, starting from this step. Finding the critical value from the appropriate table. Since this is a t-test, I'm just gonna write t-test. This is a t-test para ma-remindan ta. Of course, we're gonna be using the t-test distribution, the t-test table or the t-table. Before that, let's try to take a look at what type of test is this. This is two-tailed test. Anong two-tailed test ni siya, guys? Because we're using not equal to for the alternative hypothesis. So now, what is our alpha? Alpha is 0.05. And what is our degrees of freedom? The degrees of freedom, guys, is equal to n minus 1. The n is the sample size. The sample size given in the problem is 10 weeks minus 1. So we have a degrees of freedom 9. So let's open up our t-table here. So look at the t-table that we have, guys. Let me just take a screenshot of this ha para maka-annotate ko makasasatsuwat ko pa. Ano? Okay. So the degrees of freedom, guys, is 9. So we are going to take a look in this side here. You see this DF here? So we're going to look for 9 degrees of freedom. Here you go. I just found it. And the two-tailed test. So we're going to be focusing here. Two tails. Under those requirement, we're going to look for the alpha 0.05. So two-tail alpha 0.05 is found here, right? We just need to look for the cross section or the intersection of that alpha 0.05 with two-tail and the degrees of freedom 9. So our critical value should be this one. So in other words, the critical value that we have for a two-tailed test is positive 2.262 and negative 2.262, not triangle. So here, 2.262 and negative 2.262. There. So we already have a critical value. Now, number 3, we're going to solve for the test statistic. As I've mentioned earlier, this is still similar to z-test. However, the values are different. So we have t equals sample mean minus population mean over sample standard deviation over square root of n. The sample mean that we have, guys, is 17.7 minus population mean of 16.3 over the sample standard deviation, which is 1.8, over the square root of how many sample size did we consider? 10. So let's try to grab our calculator and solve it. I get an answer of 2.46. Positive 2.46. So since we're done with step 3, guys, we're going to be working on step 4, where we are going to decide if we have to accept or reject the null hypothesis. And that's going to be based on the values that we solve from step 3 and the step 2 that we have. So if you're going to take a look at it, 2.46 is located somewhere here, which is technically part of the rejection area. This means to say that step 4 says, or the conclusion, not conclusion, but your step 4 decision should be to reject the null, or rather the alternative hypothesis. And your step 5 to state the conclusion, you are rejecting the HO, you're rejecting this. So we can say there is enough evidence to reject the claim. Or you can make your own statement of conclusion, but make sure that conclusion would make sense. When you say it's similar to the conclusion that I wrote here, you can also say, okay, it is true then that the average number of infections per week in a hospital is not equal to 16.3. Question for that item. All right, so it seems nga wala question. I'm going to proceed to the next example. Here, an educator claims that the average salary, so what's the meaning of degrees of freedom? Degrees of freedom, Pia. Welcome. An educator claims that the average salary of substitute teachers in school districts in a local district is less than 870 per day. A random sample if 8 school district is selected and daily salaries are shown, is there enough evidence to support the indicator's claim at alpha 0.10? Assume the variable is normally distributed. So I'm going to give you 5 minutes to 7 minutes, guys, or 10 minutes. It's already 3:29, so I should get back to you at 3:39. You should have a complete answer for the 5 steps. Go. Hello? Oh, pinsan ni? Sa asa ni, sir? Ah, okay. Asa kadapit ron, sir? Dihalan sa Helen's Lechon, sir, dapin sa daan, sir. Degrees of freedom, guys, is only used when you're using t-tests. There's no degrees of freedom for z-test. Okay, wait 1 moment. Here. Maklaro ra. Let me, how about that? Is that better? 5 more minutes. Kasalanan ba? Humingi ako sa langit ng isang. Hello? Sir? Pila ka na, sir? Sige, sir. Sige, sir. Nakaisukli 1K, sir? Nagyanan ako, sir. Guys, continue answer. Just not ako i-claim, ha? Himala, kasalanan mo. Humingi ako sa himala. Hi! Welcome back! Hello, Black! I'm back! Sige. Time pa saktura. 3:39. So, what's your null hypothesis and what's your alternative hypothesis? I want to call people. Sige, ha. Dana, what's your null hypothesis and alternative hypothesis? And I'll say if your answer, or I'll confirm if your answers are correct or wrong. I'll go, Richard. So no, I think it's the other way around. The null hypothesis, that should be the statement nga no difference. So that should use the null should use the equal symbol. But you're almost there. So yes, Pia. Null should be mu equals 870. Very good. The alternative is less than 870. Very good. And you're already correct, Richard, when you say claim is the null hypothesis. You're right. Yes, you are correct. The claim here in this problem is the null hypothesis. So, imo like combine imong answer nga claim is the null hypothesis plus the answer of Pia, Francine. You guys are doing great. Now, let's work on the critical values from the appropriate table. So, what is your critical value? Very good. Everyone seems to get the correct answer, 1.415. Perfect. So it's confirmed, it's correct. 1.415. So thank you so much, Richard and Sano. What is your computed test value? Your step 3. Negative negative 84. Okay. So here. Oops. I'm gonna take a screenshot of this. So here. Sige. We're done with na screenshot yun mong patay ako. Sige, we're done with the step 1 and step 2. So we're doing step 3 now. If you notice, guys, wala tayong mean, di ba? Wala tayong sample mean. So first thing first, we need to solve first for the sample mean. It's very easy. You just have to add all these numbers, 680, 590, 890, 900, 740, divided by 8 because you have 8 numbers that you can see there. That would give you a sample mean of 828.75. Right? Kasi wakakuhaan ng sample mean. Dapat master na rin yung sample mean, guys. Sunod, we're gonna look for the critical value. Critical value. The sample standard deviation. How to solve for the sample standard deviation? It's very easy still. We have 680 minus 828.75 squared. Remember mo, ani? Plus, kumada sa 680, 590 na sa 590 minus 828.75 plus 890 minus 828.75 squared plus dot plus until such time mahurutin mo mga numbers nga na diri. So 920 minus 828.75 squared all over 8. Okay, you have 8 items man. And then after that, you take the square root of that. So your sample standard deviation should be 130.43. 130. Good question, Sano. Okay, here. That's a good question, Sano. I think, Richard, your 139.43, it's when you do n minus 1 sa denominator. Your denominator is 7. Say mo cancer, Sano? Say mo cancer? Sa inyong standard deviation with Richard? Okay, that's a good question. Let's clarify that. You do n minus 1 if your standard deviation you are solving is coming from the population and you have a sample. You do n minus 1. So for example, nakay population. No, population, you have a population. You want to solve a sample standard deviation, you do n minus 1. Pero the problem good ani nga tong problem here, guys, kani nga situation, it's already the sample size. It's already the sample. So we don't do the n minus 1 anymore because this is already taken out from the population. If you're given the population size, population ha, nakay population ng daghang data, and then you want to solve the sample standard deviation from that population, that's when you do n minus 1. Clear? Pero this problem here, we are already given the sample, man. It's already the sample. It's already assuming we have already taken something from the population naman. So we don't do n minus 1 anymore. Ang previous one lagi, sir, kay which one? Asa, kani? Kani diri? Okay, given naman siya daan. Given naman yung sample standard deviation, pero diri nga problem kani kaduha, wala pa man tay sample standard deviation. So gets na? Very good, very good. So if imo ning i-substitute, this is your mean 828.75 and this is your sample standard deviation 130.43. I think you should get negative 0.89. Can you double check? Very good. Negative 0.89 and T. Very good. So according to Pia, guys, T is negative 0.89, blah, 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 and so on and so forth. Now, step 4. Do we have to reject or accept the null hypothesis? Accept. Very good. Your answers, guys, are form of questions. Dili confident. Sige. So EJ Sano said, EJ Sano said accept. Very good. That's actually correct. Kay pila ganito yung critical value? Your critical value was negative 1.415. It's negative, ha? Very good. It's negative 1.415 kaya naman siya sa left side. So asa man na belong si negative 0.89, it's to the right. So in other words, you get to accept the null hypothesis. So, di ba? Since you are accepting the null hypothesis, can you or can anyone write on the chat box one of our conclusions, please? Go. Step 5 na ta. So can you write a conclusion? There is enough evidence to accept the claim. Very good. No. Because, di ba, ang ato ang HO ani kay ana 870 and HA less than 870. And which one is the claim? This is the claim. We are rejecting, sakto di ay, sakto, sorry, my bad. Sakto ka, Richard. You said there is enough evidence to accept the claim, so we are accepting this. I know. Dili sayop. Okay, we are accepting the HO, man. This is true. Yeah, this is the claim. We are not accepting this one, man. Di ba? Inyong conclusion is very good. That's one answer, Sano. At 10% significance, there is not enough evidence to support the educator's claim. Ang claim, ang null may accept or reject. So we are rejecting the null hypothesis, accepting the alternative. If we are accepting the null hypothesis, we are rejecting the alternative. So since we are accepting the null man ani, So, meaning to say true si null. Question. Wait guys, asa ko mga tissue? No more questions? All right, good, good. So let's work on one more item and then we're going to end this session for today. So we have here, I know we're gonna be working on two items. Sorry, and then before we end the session, um, no, only use DF. Ayaw mo pag-unahunaan ng concept kay. There is another test that's gonna be using DF SAD, which is ANOVA. But this time, based ato ang so far nga discussion, use degrees of freedom if you're using t-test. Okay? Okay? Use degrees of freedom if you're using t-tests. Are we good? All right, so let's have this. Let's have the p-value method. A physician claims that joggers' maximal volume oxygen uptake is greater than the average of all adults. A sample of 15 joggers has a mean of 40.6 ml per kilogram and a standard deviation of 6 ml per kilogram. If the average of all adults is 36.7 ml per kilogram, is there enough evidence to support the physician's claims at alpha 0.05? Assume the variable is normally distributed. All right. So how do we go about this? Using p-value method. So first, we're going to state the null and alternative hypothesis. So based on the problem, guys, this is our null and alternative hypothesis. So the null is equal to 36.7 ml per kg. And the alternative, it's greater than because of what we have here. And it's the claim as well. The physician claims that the jogger maximal volume oxygen uptake is greater than the average of all adults. So that's the claim. Step 2, guys, is, if you know, the p-value method states that step 2 would be solving for the test statistic. And you just have to substitute the values. So the sample mean, which is 40.6. And by the way, guys, the reason why it's t-test, if you notice, even though this standard deviation is not telling us if it's population or sample, however, if we're going to read that second sentence there, sentence, it says a sample of 15 joggers has a mean of 40.6 ml per kg and a standard deviation of 60 ml per kg, meaning to say this standard deviation of 6 is coming from the 15 sample of 15 joggers. The sample of 15 joggers. Okay? Mao nang t-test ang gamit. Next. So sabi siya na sa values. Sample mean is 40.6 minus population mean 36.7 over 6 over square root of 15. And that's equal to 2.517. If you're going to simplify or double check that using your calculator, you should get 2.517. Here, using the p-value method, guys, you wouldn't be able to determine the exact value of the p-value method. But what we can do instead is looking for the corresponding degrees of freedom. We're still going to be using degrees of freedom because in the first place, this is a t-test, okay? So take a look. N minus 1 is 15 minus 1, that's equal to 14. So you focus yourself sa degrees of freedom of 14 here, kaning nasud sa kaning row 14. Now, is this a one-tailed test, two-tailed test? This is a one-tailed test because the alternative hypothesis says greater than, okay? So one-tailed test. Now, sir, what happened here? What happened to this green green box, the 2.145 and 2.624? What happened? Nga nung kanii mong gisudlan og boxer? Why not other numbers? The reason is that if you're going to go back to your step 2, it says here the value that we have solved is 2.517. This 2.517 falls under or within this interval. Do you notice? Do you notice that? That test statistic at 2.517 falls under that interval. Let me just, how to view full screen mode. There. I hope you can still see it. So if you notice here, can you see the hand cursor moving? I hope so. So if you can see here, the 2.51, was it 2.51? What's that? Here, the 2.517 belongs to that interval 2.145 and 2.624. Somewhere in that interval. Mo nang gibox na ko green. And then you go up, go to one tail. Anong one tail ta? Because this is a one tail test. That corresponding alpha or significance level of these two numbers here is the p-value interval. Meaning to say, the p-value is somewhere between these two numbers or these two intervals. If we're going to go, let's go to step 4. Take a look. 0.01 to 0.025, 0.01 to 0.025. This means to say the p-value falls somewhere between or within this interval. And all these numbers here, even those, even starting 0.01 until 0.025, they are all less than 0.05, right? Which means to say, if your p-value is less than or equal to alpha, you reject the null hypothesis. Comparing these two items or numbers here, you can say that you have to reject the null hypothesis. So we are going to be rejecting, if we're going to go back to your step 1, rejecting the null hypothesis, we are accepting the alternative hypothesis. Then we can say here in our statement number 5, there is enough evidence to support the claim because we are rejecting HO and the claim is HA. So there is enough evidence to support the claim that the jogger's maximal volume uptake is greater than 36.7. Question. All right, so no questions so far. I'm going to proceed to this summary here, guys. So these are your qualifiers, when to use z-test and when to use t-test, okay? You're going to be using z-test, guys, if your population standard deviation is known or given, regardless if how many your sample size is. If your sample size is less than 30 or greater than 30, as long as your population standard deviation is given, you're going to use z-test. Now, if your population standard deviation is not known or is unknown or is not given in the problem, then you should be using t-test, regardless if your n is greater than or equal to 30 or it may be less than 30. So long as a population standard deviation is not given, you are going to use t-test. Okay? What time is it? All right. So questions so far. Wala. Let's go to the very last item that we're going to cover today. Z-test for proportion. So we are now down to 3 types of tests. Z-test for a mean, T-test for a mean, and Z-test for a proportion. Now, Z-test for a proportion, guys, only works when you are dealing with proportion or percentage, okay? So, lahi na ni siya nga concepts if you're going to read the problem. However, the steps in the hypothesis testing process would still be the same. The steps in looking for the critical value would still be the same. The steps in accepting or rejecting the null hypothesis is still based on whatever value that you're going to solve. But the formula is going to be different compared to the other. And the other thing is that if when to use this, you're going to be using this only if and only if the problem talks about percentage or proportion. So these are the qualifiers. The number of trials should be fixed, meaning to say there's a fixed number of trials, not infinite. Second, the 2 outcomes only would be considered as either success or failure, yes or no, happy or sad, buwagan ka or di. Next, number 3, each outcome must be independent, meaning to say if success siya, the second outcome should not affect the first outcome, which is a success. In other words, if gibuwagan ka, sa second imong uyab, kung gisugot ka, dili mo affect ang resulta ani sa imong first nga uyab. And that's it. So here is the example. So if we're going to read the example, ladies and gentlemen, it tells us a dietitian claims that 60% of people are trying to avoid trans fats in their diets. She randomly selected 200 people and found that 128 out of 200 people stated that they were trying to avoid trans fats in their diets. Test at alpha 0.05. Is there enough evidence to reject the dietitian's claims? So if you notice, guys, if you notice, everyone, we are no longer dealing with mean. We did not, in fact, mention the word average as well as a standard deviation. What we have here is 60%, which is proportion of the total population. So with that being said, we're going to be using the z-test for proportion and an example. So I'm going to take a screenshot of this. Alt. How to escape? Okay. Here. I'm going to take a screenshot of this one. And then paste it on whiteboard. Here. And also, I'm going to take a screenshot of the formula as well that we're going to be using to solve this item here. There. All right. So we are still going to be doing the same steps as I've mentioned earlier. So the null hypothesis, guys, since we are no longer using the mean, we are no longer dealing with proportions. So we are going to use letter P, which stands for the first letter of the word proportion or percentage. So P still equals 60%. Or you can write P equals, sorry, that should have been 0.6. 0.6. Amen? Alternative hypothesis, it didn't say nga kuan siya. It didn't say nga less than or greater than. So what we're going to be using is not equal to. Or P equals, not equals 0.60. Okay? That's the first step. The second step, guys, is knowing the critical value. Now, since this is a two-tailed test, notice two-tailed test because of the alternative, you then divide your alpha by 2. Your alpha here is 0.05 over 2, which give us 0.025, right? And that means to say that 0.025 is the area that we're going to consider. So here, 0.025, so shade that. Here as well, 0.025, shade that. But our concern here is we want to look for the critical value. What's here? Now, we know that the half of the graph is 0.50. If we're going to subtract this from 0.50, this area here would be 0.4750. You can try to confirm that using your calculator. Now, in our Z table, because Z table man siya, we're using Z test man. We're gonna be using Z test. So we're gonna be looking for the 0.4750. Asa kahana? Akong mata baka nakatubang na sa computer from 7:30 to until this very hour niya. Murag ka ng mukha na siya. Murag mo do nag-contacts ko. Wala may right anti-rad akong contacts ko. Pero na siya grado. So let's work on, according to EJ 1.96, let's work on that. So here, 0.4750, we trace it to the right, to the left rather, 1.9, and then going up 1.96. Very good. So the critical values that we have, because since this is a two-tailed test, EJ, we should have negative 1.96 and the other one positive 1.96. Amen? And then we're going to solve for the test value here. Step 3. I'm going to define first each variable para makita niyo sa ang pag-substitute. So the p hat, guys, the p hat is the proportion of the sample that agrees to the statement. So out of the 200 people, how many people stated that they were trying to avoid trans fats? So that's 128 out of 200. And I believe that's equal to 0.64. Can you confirm it? Yeah, it's 0.64. And then, you know, P is already given. P is equal to 0.60. The Q, guys, is equal to 1 minus P. So 1 minus 0.60, Q is 0.40. And, you know, N is the total number of sample size being picked. And that's 200 people. So let's substitute the values to solve for Z. Z is equal to P hat is 0.64 minus P, which is 0.60, over the square root of 0.60 times Q, which is 0.40, over N, which is 200. So using our calculator, our magical calculator, 0.16. I have 1.15. Okay, so we have our step 3. We have computed our test value, which is 1.15. Let's work on step 4. We're going to be deciding if we were to accept the null or reject the null hypothesis. So where do you think is 1.15 lands if we're going to look at this illustration here? Asa na belongs to 1.15? It's clear that 1.15 is located somewhere here. No? 1.15? Somewhere there? Meaning to say we're gonna accept the null. And step 5 is to conclude. Since we're accepting the null hypothesis, this is true. We can say that indeed, yes, it's true. Yes, it's true that 60% of the people avoid trans fats in their diets. Question. That's it for this afternoon, guys. That's technically it for this afternoon. So I'm gonna upload another set of assignments. Same thing, guys. So do not forget also that we're gonna have a quiz on May 7, Friday at 3 p.m. what may be optimized for video clip? Okay. Any questions? I can tell, Velos. I can't say. All right. I think everyone has no questions at this time. Friday, April 7 at 3 p.m. All right. I'm going to stop recording na guys, ha?